So actually the purpose of this video is to show you how to use Desmos to calculate Riemann sums, because it gets a little bit tedious, but here's the heads up. If the number of subintervals is 4, by the way, this blue graph is the graph of this function right here, then the width of each little subinterval is b minus a over n, which in our case, b is 3, a is 0, 3 minus 0 is the length of the interval. Divided into 4 equal subintervals, we get 3/4 or 0.75. And so to calculate the height of each rectangle, we have to create these left-hand endpoints along the x-axis. Starting at 0, we go up by 0.75 each time. And these are the values that we plug into the g function in order to get the height of each little rectangle. Then we multiply that by the width, which is 0.75, to get the area of the first rectangle, or the 0th rectangle. And we're going to do this for a sub 1, a sub 0, a sub 1, a sub 2, and a sub 3. They'll actually be 4 rectangles. So we'll add those areas together and we'll have an approximation for the true area under the curve, but it will be an approximation. But I'm not going to do all these calculations. I'm going to go to Desmos to do it. So I'm going to share my screen, go to Desmos, and I will be providing a link to this graph and the solution. But here's the original function. You can change this to anything you want. Here where you specify the left and right hand endpoints. So I specified it as 0 and 3. I could change this like this, slider. Okay, but there's our original. N is the number of subintervals. And you can see if I increase them, the number of rectangles increases dramatically. Go back to 4. And by the way, the more rectangles you get, the closer you are to the true area under the curve. This value of C down here controls whether you're using left-hand sums, right-hand endpoints, I should say, or midpoints. You can do midpoints too and get an integral approximation. I'll go to left for starters. And this little table right here is where you can actually see the calculations that are performed. These are the left-hand endpoints of each subinterval. Here I've plugged in S of x sub I into the f function in our case instead of g. So if you had to actually show your work, you could come here and get the area of each of those rectangles. I'm sorry, the height of each of those rectangles. And over here, that's the area of each of those rectangles. And then add them together. Well, that's what this is right here, adding them together. So from I equals 0 to n minus 1 of f of s sub I, f of s of I is actually the height of each rectangle at each left-hand endpoint times w. So there's the approximation right there for what you get for the area of 4 rectangles. Actually, here's the true area right here, the definite integral from a to b. You can see it's quite a bit under the actual area. Okay, so we'll jot down what we get for left-hand endpoints. It's 18.515625. I'll change it to right-hand endpoints, and we get 27.515625. And we want the that's what the question asks. Take the average. Oh, and what I meant to mention down here is if you have an additional interval, then you have to add rows to this table to see what else is happening. But for now, we'll just leave it at 4 subintervals. Okay, and you could do the calculation here if you wanted to. You could type in 18.515 plus 27.51526, divide by 2, and you'd have the average. So that's what they do, left-hand and right-hand sum. So the left-hand sum was 18.51. I'll just say 52. Right-hand sum was 27.52. Add those together, divide by 2. The true area is 21.75. So I wonder how close that is. Well, this adds up to 35 or 36, 18 when you take half. So it's not really very close. That's why you need to let the number of subintervals, the number of rectangles approach infinity. Okay, there you go. Hope that helped. And I'll be providing the link to the Desmos graph.